All right, so just like the ones that we did, very similar to the ones that we did on Friday for the half angles. We have double angle problems that look similar. So 18 tangent of A is equal to negative square root of 3, and it's from pi over 2 less than A less than pi. And we're finding sine of 2A, cosine of 2A, and tangent of 2A. So I need to set up a triangle. So where is this? What quadrant? Quadrant 2. Tangent is opposite over adjacent, so this is going to be root 3 and negative 1. Okay, because root 3, since it's in the top, has to be positive, so that means the negative has to be on the 1. So what is the other side? It's a special triangle. Yep, it's a 30, 60, 90 triangle, so it's 1, 2, root 3. So that's side 2. So from the formulas, I know I'm going to need the sine of A, which is root 3 over 2. Cosine of A is negative 1/2. And tangent of A I was given, but just to rewrite it as negative root 3. So now I need to find the sine of 2A. Now, if I remember correctly, okay, it's cosine that has a couple. So sine of 2A, the formula is 2 sine A cosine A. So now we just replace these with the values that we found up here. So this would be 2 times root 3 over 2 times negative 1/2, which is going to end up being negative root 3 over 2. All right, cosine of 2A has multiple formulas. Which one do y'all want to use?
One minus 2 cosine. Not 1 minus 2 sine squared A.
1 minus 2 sine squared A. And just as a reminder, sine squared of A is equal to the sine of A squared. Okay, so when we're plugging stuff in. So 1 minus 2 times sine of A is root 3 over 2. So root 3 over 2 squared. So that's going to be 1 minus 2 times 3 over 4. 2 and the 4 reduce. So then I've got the 1 I'm going to rewrite as 2 over 2 minus 3 over 2, which is negative 1/2. And again, you don't necessarily have to show all of that if you can do that part in your head, but just so you can see it, I write it out. All right, I think tangent, this one just has 1. Yeah, it does. Okay. So then the last one they want us to find is the tangent of 2A. So this is going to be 2 tangent of A over 1 minus tangent squared of A. And just like I said up here with sine, tangent works the same way for the squaring part. So tangent of A was negative root 3. So 2 times negative root 3 over 1 minus, in parentheses, negative root 3 squared. Okay, and it's important that we write it that way with the parentheses because this negative is getting squared. This negative and this negative aren't disappearing and becoming positive, okay? This negative is getting squared, and then it's going to be 1 minus that value. So on top, I'm going to have negative 2 root 3 over negative root 3 squared is just positive 3, so then 1 minus 3 would be negative 2, which is going to simplify to square root of 3. All right, another one, 20. Cosine of A is equal to 2 over 5. Negative pi over 2 is less than A is less than 0. So where does that mean this triangle is going to be? Yep, quadrant 4. So it's going to be, so it's going to be down here. So we have 2, 5. Other side would be square root of 25 minus 4, so square root of 21. But what must be true about that?
Has to be right.
It's got to be negative because it's going down. So it's going to be negative square root of 21. So make sure you pay attention to that when you're doing these. I mean, I know we've done a lot of different things where you've had to set them up before, but just make sure you pay attention to signs because you don't want to throw like a whole bunch of answers off because of that. So sine of A would be negative square root of 21 over 5. Cosine of A was given to us, 2 over 5. And tangent of A would be negative square root of 21 over 2. So sine of 2A is equal to 2 sine A cosine A. So 2 times negative root 21 over 5 times 2 over 5. So that's going to be negative 4 root 21 over 25. And obviously, if it's anything that you could reduce, you should reduce it, but we can't do anything with these ones or with this one. All right. Pick a different formula for cosine of 2A than the one we used last time, just so we use something different. I don't care which one, just not the same one. Yep, cosine squared A minus sine squared A. So cosine of A is 2 over 5, so it'd be 2 over 5 squared minus sine squared of A would be negative root 21 over 5 squared. So that's going to be 4 over 25 minus negatives going away, or negative is squared. Square root of 21 would be 21 over 25. So that is going to be negative 17 over 25. And then tangent of 2A. We've got 2 tangent of A over 1 minus tangent squared of A. Tangent of A was square root of 21 over 2. So 2 times square root of 21 over 2 over 1 minus, oh wait, that was negative, wasn't it? Don't forget that. Negative there. Negative 21 over 2, or negative root 21 over 2 squared. So on top, 2's cancel. So I'm just left with negative root 21 over on the bottom, 1 minus 21 over 4. I'm going to rewrite the 1 on the bottom as 4 over 4. So negative root 21 over negative 18 over, nope, negative 17 over 4. Then keep, change, flip, it's going to become positive. So 4 root 21 over 17. For these problems, when you're doing sine and tangent, you don't necessarily need to write the formula out. You can just replace the numbers. But I do want to see with cosine which formula you're using, just so I can make sure that you're using one. So I always like to start out by writing it, but if you're like, I don't like writing it every time, you need to do it for cosine just because there's 3 different ones you can pick from, but sine and tangent you don't have to unless you just want to. So this book doesn't do any other solving in terms of double angles, aside from the way these are set up like this, where they give you the information, you draw the triangle and set it up using the formula. The only other thing that they do is simplifying expressions where we need to rewrite stuff and simplify it down. We can't have any half angles or double angles left in the problem at the end. Okay, so basically everything just has to be rewritten in terms of something else. So it's kind of like when we did 14.3 and 14.4. This will kind of look like that, is what the rest of this section is that we're doing. So, and it says given that theta is from 0 to pi over 2, so that just means that it's, in quadrant 1, which makes it nice and easy to work with. So 22, sine of 2 theta over 2 cosine theta. So I need to rewrite double angles and half angles in terms of like what they can be rewritten as. So sine of 2 theta can be rewritten as 2 sine theta cosine theta over 2 cosine theta from the bottom. Then we're canceling things that we can cancel. So 2's cancel, cosines cancel, and I'm left with sine theta. Uh, 24. Cosine 2 theta over sine theta minus cosine theta. So cosine 2 theta has 3 different ways that it can be rewritten, right? I want to find one that looks as basically similar as possible to what I'm trying to cancel out on the bottom, okay? And you may get to a point and you realize you picked the wrong one and you have to pick a different one. But what formula of cosine of 2 theta involves sine and cosine? Because that's where I would typically try to start myself. Cosine squared theta minus sine squared theta over sine theta minus cosine theta. So, before you tell me to cancel top and bottom cosines and sines and all that stuff, I need to do something else with the top, okay, to, like, basically rewrite that.
Do you take the sine theta minus sine theta and then parentheses, like have it parentheses but square on the outside?
That would not be equal to the same thing. But you're kind of on the right idea of something that I'm going to need to do. If you had x squared minus 4 squared, and I told you to factor that, how would you write that?
X minus 4 squared.
It's a special type.
Do you take the square out of it?
It'd be like x plus x.
Does difference of squares ring a bell? How would I write that then?
Parentheses x minus 2,
Well, I have 4 squared, so
4,
yeah.
and then square.
Nope,
X plus 4.
x plus 4.
Oh.
So I'm going to do that with this, okay? So this is going to be cosine theta minus sine theta times cosine theta plus sine theta. So this is over sine theta minus cosine theta. But can I cancel that still? No, I cannot. Okay, because these signs are different here. Okay, like they're both negative, but they're on the wrong term. But what I can do is I can factor out this negative here. Okay, or I could do it on the top, but I'm just going to do it on the bottom. Okay, I can factor out this negative here and make this on the bottom negative parentheses cosine theta minus sine theta. Because when I multiply this back through, I get back to what I originally started with. Okay, mathematically I am allowed to do that. So then I have the cosine theta minus sine theta times cosine theta plus sine theta on top. Now what? Now I can cancel. So I'm left with this negative on the bottom, but it can be moved up to the top. So negative parentheses cosine theta plus sine theta. And you can either leave it there or you can multiply the negative through, but I would just leave it like that.
At the top, couldn't you just cancel the sign and then cross out the, oh,
Alright, so those were all double angles. Let's do a half angle one here, and then we'll be done. It's the last problem. 26. 2 times sine theta over 2 cosine theta over 2. So I need to rewrite those half angles in terms of their other formulas that we have. So what is the formula for sine of theta over 2?
Plus or minus.
So yes, it is plus or minus, but we're in 0 to pi over 2, so they're all going to be plus.
Square root of 1 minus cosine n over 2.
Yep. 1 minus cosine for the sec theta, but yes, over 2. And then what is the formula for cosine theta over 2.
Plus radical 1 plus cosine theta over 2.
Yep.
Okay.
So this is also why it was important in the problem, okay, that they told us that it's from 0 less than theta less than pi over 2, because that means that that angle is going to be in quadrant 1, which means everything's going to be positive, because otherwise I would be dealing with the negatives and all that stuff on the radicals. So I need to multiply this now. When I multiply radicals, okay, I can multiply the stuff that's inside of them. So this is going to become, the 2 staying on the outside, but I'm going to have one giant radical, 1 minus cosine theta times 1 plus cosine theta over 2 times 2 is 4. So what do I have on the top? Special type.
What's the difference of squares? It's
Yep.
2, okay.
So it's a difference of squares, so it's going to be 1 minus cosine squared theta. So 2 times the square root of 1 minus cosine squared theta over 4. And what's 1 minus cosine squared theta?
Cosine theta.
Huh?
Negative sine squared theta.
Not negative.
Cosine theta.
Yep. Okay, it's a Pythagorean identity. So sine squared plus cosine squared equals 1. So 1 minus cosine squared is going to be sine squared. So this is going to be 2 square root sine squared theta over 4. And what does this reduce to inside here? Just remember, I can rewrite this as 2 times the square root of sine squared theta
Sine theta.
over square root of 4. So, yep. So, on top, I'm going to have 2 sine theta, and square root of 4 is 2. So, when it's all said and done, I'm left with sine theta. So, you can't forget identities from 14.3 and 14.4. You have to have those still to solve these. Any questions on this stuff from today? Okay. So in addition to the problems you had from the other day, for some reason you hadn't finished them, you need to do 17, 19, 23, actually 21, 23, and 25.